Hi everyone, my name is Amitesh, and in this video we're going to talk about simplifying expressions involving the absolute value. Now, typically in problems in math you might have some expression which has the absolute value intertwined in there, and what you want to do is you want to be able to simplify it so you can get rid of the inessential information and just focus on what's essential. And this video will just talk about it. When you see an absolute value in some expression, how we can just actually figure out what this actually means and sort of just get rid of the absolute value where applicable. So let's get started. So we're going to talk about expressions with the absolute value. I'm going to give a few prototypical problems, so expressions with the absolute value. So I'm going to talk about expressions on certain intervals, and in a previous video I've talked about intervals. So if you haven't seen that video and you're not sure about what intervals are, you can check that out, links in the description. And similarly, if you haven't seen the absolute value before, I've also talked about that in another video and just from the basics, and so link is in the description for that too. Okay, so let's talk about the first problem here. So the question is going to be simplify absolute value of x minus 5 on the interval 5 infinity. So 5 infinity is the interval, is all numbers greater than 5. Okay, so you don't actually have to know what intervals are in some sense in this video. We kind of will talk about it, but 5 infinity is all real numbers greater than 5. And we want to simplify absolute value of x minus 5 on this interval, which is to say we want to figure out what it really is. Now, the thing to always keep in mind is what is the absolute value? We have a definition for that. We know that when the thing inside the absolute value is positive, we know that it's just the same thing back. And when the thing inside the absolute value is negative, we know we have to take the negative of that to get a positive number which represents the distance from that to 0. So in this case we just need to figure out when is this absolute value of x minus 5, which I'm just going to kind of draw with this marker. So when is this absolute value of x minus 5, when is that x minus 5 going to be positive or negative? Okay, so observation is that x minus 5 is positive. That happens when x is greater than, or even x minus 5 is at least 0. That happens when x is at least 5, right? And similarly, if we add 5 to both sides of the inequality, and similarly x minus 5 is less than 0, that happens when x is less than 5. So what does that tell us about the absolute value? It tells us that the absolute value of x minus 5, we know what it's going to be. So we know that the absolute value of x minus 5, so when x minus 5 is at least 0, it's just going to give it back to us as x minus 5. So that's going to be when x is at least 5. And when x is less than 5 and the quantity in the absolute value is negative, we're going to get minus of x minus 5 for the absolute value. So here we're going to have minus of x minus 5 when x is less than 5, which you can also simplify. So I'm just going to simplify that here. That's just going to be 5 minus x. Okay, so that's the formula. Now, it's just always with the absolute value, think about when the thing inside the absolute value is positive or negative. That's the first thought to keep in mind. Okay, so now we've done that, we actually need to know one of these pieces of information, because what we can do is we say that on the interval 5 infinity, x is greater than 5. So actually the absolute value of x minus 5 is just going to be x minus 5, because when x is greater than 5, we know that x minus 5 is going to be greater than 0. So here we can just say as a solution to our problem, we can say that the absolute value of x minus 5 is just equal to x minus 5 on 5 infinity. So this is the first prototypical example of one of these questions about simplifying the absolute value. The main thing to keep in mind is just think about when the thing inside the absolute value is positive or negative. And we're going to do another one now. So I'm just going to erase this and get to the next question. Okay, so we're just going to change the question slightly. And the question is now going to be simplify absolute value of x plus 9 on the interval minus infinity minus 10. Okay, so minus infinity minus 10 is all numbers that are less than minus 10. And for those numbers, we want to figure out, those x's, we want to figure out what is the absolute value of x plus 9. So again, when is this absolute value of x plus 9? When is it positive, or at least 0? Absolute value of 0 is also 0. And when is it negative? Okay, so we just solve that inequality. First step, it's just an algorithm in some sense. Just take x plus 9. When is it at least 0? Right? Ask yourself that question. And so we can ask ourselves that question. X plus 9 is at least 0. That happens when you subtract 9 from both sides, when x is at least negative 9. Okay, so we know that that's true. And then we know that the reverse is true when x is less than negative 9. You know, we don't have to resolve the inequality. We know that x plus 9 is less than 0. That happens when x is less than negative 9. Okay, so now the next thing, once we've dissected what the absolute value is, what the thing in expression inside the absolute value expression is, when is it positive, when is it negative, we can then look at our interval and we say on this interval we know these are all numbers less than negative 10, so we know x is less than negative 10. Okay, and here we see that when x is less than negative 10, of course x is less than negative 9, so we've got a perfect matching up, and we say that in this case x plus 9 is negative, right? So to solve the problem, we now know that x plus 9 is negative on this interval, so the absolute value of a negative number, you know, you can always just go through it in your mind if you like. Absolute value of negative 5 is 5, because negative 5 is 5 units from 0. It's always the distance to 0, so it's always a non-negative number. And so when x plus 9 is negative, the absolute value of x plus 9 has to be the negative of x plus 9. So it's going to be negative of x plus 9, which we can also write as negative x minus negative 9. Okay, so the answer to that problem is negative x minus negative 9, and it's always good practice to say on the interval minus infinity minus 10. Okay, so this is one of those cases, this is an important example in math of equations being conditionally true. So the equation saying that absolute value of x plus 9 is minus x minus 9, it's not always true. You know, it's false if x is greater than or equal to minus 9. For example, if you take x as 0, you're going to get the absolute value of 0 plus 9 is the absolute value of 9, which is just 9. But here, if you put x equals 0 in minus x minus 9, you'll get minus 9, which is the wrong answer. But on this interval of minus infinity to minus 10, we know that this equation is true. In fact, it's true on the interval minus infinity to minus 9. But this is a conditional equation that's true with some specification. Okay, so we've done that. So now the next thing we're going to do is a combination, so slightly more subtle problem, which is going to involve multiple absolute value expressions in one. Okay, so let's amp up the difficulty a bit. So remember the steps. You see an equation or expression with the absolute values. Ask yourself when each quantity in each absolute value, when is it positive, when is it negative? And if you're given the interval, you can just look at that interval and ask yourself that question rather than generally solve that. And then unwind it out. And we'll see an example of this again shortly. So this is the next one. What we're going to do is simplify. I'm going to write this out. Absolute value x minus 3 minus absolute value x minus 4. Sorry, I put a brackets there, so it should be that, on the interval 3, 4. Okay, so that's going to be our question to simplify this expression on the interval 3, 4. Now, same steps. So think about the things inside the absolute value. Sorry, I got the wrong pen. I've got two different blue markers, so I'm using the bullet marker now. I like that a little better. So we have x minus 3 and x minus 4. Now x minus 3, instead of asking ourselves when x minus 3 is positive or when it's negative, let's just think about the interval and answer the problem that way. Okay, so we don't need to do the more general thing. We just look at, on the interval 3, 4, is x minus 3 positive? Well, the interval 3, 4 is all numbers between 3 and 4. So they're all numbers greater than 3 and less than 4. And you can kind of imagine this on the number line as well. So you have 0, you have 3, you have 4, and your x is sitting in here. And you can sort of see that, x is some prototypical point in that interval. We don't know what it is. But you can sort of see that x minus 3 will be positive on that interval. And you can also see x minus 4, because 4 is greater than x minus 4 will be negative, right? So that's really cool. So on the interval 3, 4, we know that x minus 3 is going to be positive and x minus 4 is going to be negative. That's what we care about. On that interval, what are the signs of the things inside the absolute value? And now we can strip away the absolute value using the definition, which basically tells us that when a number is positive, the absolute value gives that number back. And when a number is negative, the absolute value just puts a minus sign to that number to make it a positive number. Okay, so here we're going to say that the absolute value of x minus 3 on 3, 4, so this is all on this interval 3, 4, is just going to be x minus 3 back. And the absolute value of x minus 4 is just going to equal to the negative of x minus 4. Okay, so sometimes it's a bit confusing because you say, okay, you're taking the negative of something. Isn't that negative? But remember, when you take the negative of a negative thing, it's positive. So the absolute value of x minus 4 is the negative of x minus 4, and x minus 4 is negative. So we're just going to get this is equal to 4 minus x. Okay, so this is all on the interval 3, 4. So now we can get rid of the absolute value signs. I'm just going to rub this off here. Okay, so let's rub this off. And let's just write this out on this side of the board. We know that the absolute value of x minus 3 minus the absolute value of x minus 4 is going to be something interesting actually, mildly interesting. It's going to be x minus 3 is positive, so we just use these things we just worked out here. So use that there, we're just going to get x minus 3 minus of 4 minus x, okay? So minus of 4 minus x, a minus of x minus 4, which is 4 minus x, sorry. And that's just going to equal to x minus 3 minus 4 plus x. And yeah, so we just have to be careful with the minus signs. I mean, this is something like everyone, like no matter how many years you've done math, you always want to be careful that minus of minus is plus, because sometimes you have complicated expressions, you do it in your head. This happened to me many times. I make one sign error and then the whole thing goes wrong. And then I have to go back through it and then I find, oh, okay, this sign error is the thing. So it's pretty common, but here it's pretty simple. It's not too extensive, not too many signs here, but we get x minus 3 minus 4 plus x, and that's just going to equal to 2x minus 7. Okay, so that's what the expression is on the interval 3, 4. And this is cool, this is a formula. So if you have a problem, right, and your problem is implicitly considering numbers in the interval 3, 4, between 3 and 4, and your problem somewhere has this expression, absolute value x minus 3 minus absolute value x minus 4, you can just say it's 2x minus 7, which is something that should be more familiar. So this is the power of just having a sense. In addition to practicing with the absolute value, it's just understanding you can simplify it when you have a domain in question. Okay, in general you can't. So in general, if I asked simplify this absolute value x minus 3 minus absolute value x minus 4, and I did not have the 3, 4, I just like sort of took this out here, there would be no answer really. I mean, you could give an answer, but you'd have to basically say on 3, 4, it's 2x minus 7. Then on minus infinity 3, it would have a different answer. And on 4 infinity, it would also have a different answer. Okay, so that's something as an exercise one can try to actually understand what it should be on the other intervals. But you'd have a piecewise definition where you'd have to say what it is on each interval. But here you can just sort of, on 3, 4, you can just write it as a formula. Okay, so that's one example. Now let us kind of do one last example. Couple of last examples which I think are pretty cool, and they look pretty cool at least. So here's the example. So the next example, and this is not going to have a domain in it. Okay, these examples are not going to have domains. So you can simplify absolute values even when you don't have a domain. So simplify the absolute value of 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 x write that out. Okay, so 5 absolute values. What is that going to be? We can even just say, to make it a little more interesting sounding, let's just say absolute value of something like x plus 3 or something. Okay, what is this going to be? Now, how do we think about this? So, if you don't see this before, sometimes it looks a little bit weird, what's going on. But the trick is that the absolute value of x plus 3, ask ourselves what happens when you take the first absolute value. Abstractly, we're making the number non-negative. If x plus 3 was negative, we would take the negative of it. If x plus 3 is at least 0, we would just keep it as x plus 3. But whatever the answer is, it is always a non-negative number. This is a fundamental property of the absolute value. It not just comes up in this problem, but in general, always keep in mind that the absolute value of something is a non-negative number. It's just a good sanity check. If you're getting an answer, you should always get a non-negative answer if it's just the absolute value of something. So we know this is at least 0. But now here's the cool thing. What happens when you take the absolute value of something that's at least 0? Well, you just get that back, because the absolute value of a number at least 0 is just the distance from that number to 0 is just that number. Distances are non-negative. If the number is already non-negative, we get it back. So what happens is, after you take the first absolute value, the remaining absolute values are all redundant, because you already have a number that's non-negative. You're just going to keep getting it back every single time. So it didn't matter if we had 100 absolute values or 5 absolute values. The answer here is just going to be equal to, I'm going to write it down, it's going to be equal to the absolute value of x plus 3. Okay, so that's there. So just a sort of a quick sort of mental warm-up with, what is the basic property of the absolute value, that it's always non-negative. Final question, simplify absolute value of x plus 2. What is this going to be? So for this, again, the thing is, when you have repeated absolute values, think about the non-negative thing. The absolute value of something non-negative is always giving it back. So if we have absolute value of x plus 2, then we can basically say that, absolute value x is always non-negative. So that's something to keep in mind. And if you add 2, so this thing is always non-negative. What happens if you add 2 to something that is at least 0? And from the absolute value perspective, the question is, what is its sign? Is it positive or negative? And the answer is, it's going to be non-negative. It's going to be positive. Because if you add 2 to something that's at least 0, you get back something that's also at least 0. So the bigger absolute value is redundant again. So you're just going to get absolute value of x plus 2. So you can't simplify this further, because, and even in the previous question, you couldn't have simplified this further, because the absolute value of x, depends on x, depends on whether x is positive or negative. And similarly, the absolute value of x plus 3 depends on x plus 3, or indirectly on x. But this is as far as you can go. And perhaps one more example which I will give you, and I want you to think about this a little bit. Maybe pause the video, and as a little bit of a challenge along these lines, try to understand the following. So simplify absolute value of, let's say, minus 2 minus absolute value of x. Okay, so what is that going to be? So simplify that expression. So pause it and try to think about it yourself, and then we'll come back to it. All right, so I'm going to start now. So absolute value of minus 2 minus absolute value x. Again, the question is, what can we say, with absolute certainty that something inside the absolute value is positive or negative? And in this case, we know that the absolute value of x is always at least 0. It's a distance, so it's always at least 0. But minus the absolute value of x is always less than 0. And if you further subtract a 2, you're going to get something that's still less than 0. And remember that the absolute value of something less than 0 is the negative of that thing. So this is just going to equal to, so I'm just going to write this down here, absolute value minus 2 minus absolute value x is just going to equal to the negative of negative 2 minus absolute value x, which is going to equal to 2 plus the absolute value x. And that's going to be the end of that problem, so we can't simplify it further. Okay, so that's it. So some problems, I'll try to do some more videos, on some more problems. You can go on doing problems, and there's some cool questions. Let me know what you think. If you have any comments, questions, thoughts, feedback, I'd love to hear them. It would mean a lot. I'd be very excited to receive your comments, and I'll definitely read all of them and do my best to reply. Thank you so much for listening. I hope you loved the video, and as always, it would mean a lot to me if you could please like and subscribe. It's free, it takes less than a second, and if you love the video, it'll help to disseminate this video to others who also love it and can benefit from it. Because my ultimate goal is to create free, accessible, math education worldwide, and the more people listen, the more people, watch, it keeps growing, and liking and subscribing is a big part of that. So thank you so much. I hope you have a wonderful day. It meant a lot to me to create this video, and I wish you all the best wherever you are in the world, whatever time it is. And I'm super excited to see you in the next video, engage with you in the comments, etc. So hope you have a wonderful day, evening, or night, and I will see you soon.